Let's get this kicked off. So this morning's session is from William Killian, and he will be talking about reproducible development environments with Docker, Visual Studio Core, and Devcontainers. William is an assistant professor of computer science at Millersville University, my alma mater. That's awesome. His research area includes predictive modeling, programming models, program optimization, and computer science education. At Millersville, he teaches a wide variety of computer science courses. He maintains the Auto Lab auto upgrading platform and supports development workflows for students. Prior to joining MU, he worked at Intel and Lawrence Livermore National Laboratory, where he focused on application fitness, optimization, performance modeling, portability abstraction, application tuning, and accelerating multi-dimensional physics applications. He continues to collaborate with LLNL on the open source RAG8 portability abstraction layer and camp libraries, and he makes it easy for users to create scientific applications which run on supercomputing systems. So with that introduction, I turn it over to Will to get us started for today. Thanks, Will.
Thanks, Charlie. Okay, all right, I just want to make sure there wasn't feedback there. Thanks for coming to my talk. As Charlie said, I'm Will Killian. I teach at computer science at Millersville University. And the focus of my talk is on how we can have development environments that are pre-configured and already ready to go and set up to help either new people learn how to use different languages without the need to know how to set up an entire development environment. So, this is pretty cool stuff. At the foundation, it does use Docker, and I'll have a brief overview of what Docker is as well. So, all right, next, if I can advance the slide. All right. So just some background and disclaimer. CPOS, Central Pennsylvania Open Source Conference. I grew up in Lancaster. I went to Penn Manor High School. I got my undergrad at Millersville, went to Delaware for my master's and PhD. Charlie already covered my research interests. I do have two disclaimers. So any opinion that I state is my own personal one. And a lot of this information I generously source from open source repositories and documentation that I'll include at the end. So just an overview on the outline of this talk. I'm going to provide justification as to why this might be a good idea. I'll go over the basics of Docker, which will include how to build a container, specifying the Docker file syntax, actually using and starting a container. Then I'll pivot over to using Visual Studio Code and the Devcontainers extension that Microsoft released. So installing and configuring the extension to use with any sort of code that you want. At the end, I'll have a demo that hopefully will finally work. I also encourage you that if you do have any questions, you can either type in the chat, and I'll survey the chat every so often. So if you do have questions, please feel free to interrupt me. That is perfectly acceptable. Well, as to why even use Devcontainers, I must admit that this is sort of where I started, is that I wanted to see if I could do it. And I really didn't stop to think, should I? And I started working on this in the spring before COVID even happened. So I just had to include some sort of meme. But I continued to vet this out and realize, hey, this would be a good idea. Given that we would have about 260, 270 computer science majors who used to be able to work on assignments and programs in the university. So we have 2 labs, and now students would be forced to learn remotely, and some of the languages that we teach aren't necessarily the easiest to set up. So students would be learning remotely, not on campus, so students can't access the computer labs easily. And if they could remotely access the labs, we have 27 machines that students can SSH into. They'd be limited to a terminal and using whatever applications are available through the command line interface. And if we had, a decent subset of the students that were relying on connecting to the computers, we have about 200 students actively taking courses using 27 machines. 10 users per machine in the worst case is not necessarily a good idea. Also, if we wanted to provide, setup instructions for students to get their own development environment ready to go, there's various operating system variances, whether or not they're using Windows 7, Windows 8, Windows 10, Mac OS, various Linux distribution, etc. And then they could be working on their own computer and submit an assignment, and then our grading platform could be different than what they're using. And so they could have something that works just fine for them, but when they submit it, it doesn't work. And so then it's more of an issue on us as educators to figure out, well, how can we fairly grade this? So there's a huge motivation for actually wanting to ensure that, hey, students can have a sane development environment for what they're trying to do. The general goals of reproducibility or having reproducible development environments is first and foremost, we want to minimize the pain points for troubleshooting. If you have variances in operating systems, variances in software, in compilers, and library versions, and things like that, it becomes a cross product, so multiplicative. Now it's just a single configuration. I just have to configure it once and only provide directions on how to install Docker on their computer and maybe install Visual Studio Code in a single extension. The other main goal here is that we can provide a usable environment for students. If the students don't have to worry about configuring software, they can focus and spend more of their time on meeting course learning objectives. It's consistent for everyone. And by maintaining this consistency, it means that what they submit or what they develop on is the exact same thing as what they're being evaluated on. So it ties into just having everything working, which is pretty convenient. But it's not necessarily something that was easy to get going. For background, with the department infrastructure that we currently have, we have a Linux lab, which is remotely accessible, has 27 Dell Precision workstations with Skylake processors, 16 gigs of RAM. We use a Linux distribution, which is probably not the most popular for computer science education. We use Arch Linux, which is a rolling distribution that has latest kernel and packages. The reason for this is, it's nice to have the latest and greatest stuff at the cost of, maybe an upgrade every now and then doesn't go quite as well as planned. But we can really have a minimal lean installation, which is convenient. We also have an AutoLab server, which is used for autograding, and that's deployed on a new virtualized infrastructure where this particular virtual machine has 16 gigs of RAM allocated, I think 4 CPU cores out of the 22 for that Intel Xeon processor. The host OS is Arch Linux, but what's nice is we can use any Docker container for grading. So essentially what we can do is provide a Docker image that is representative of the Linux lab and the software stack that we have installed in the Linux lab. And so when students work on assignments, we guarantee that consistency. So what we want to do is take this existing Docker container and allow students to use that container for their assignments and their projects. So we want to containerize all of the things. Now, what types of things do we care about? Well, for those of you who don't have any experience with Docker or what a container is, I just want to provide some brief background. It's basically bundling up an instance of an operating system that doesn't really include the kernel. It contains libraries, system resources, compilers, language tool chains, any files that you would want. You could theoretically build an entire application and host it within a container. You can have scalable components and running individually in containers and replicate those containers for fail-safe measures, etc. But fundamentally what we're doing is we're bundling up all of the software that we want students to have and making it easy to deploy to them. So we can actually have this uniform development experience because we can have the operating system files, the language tool chains, and all the libraries and tools that they might use. So what we want to do is define our own containers in some way. And we can do this through the use of something known as a Docker file. And a Docker file is a recipe on how to build a container. And the only thing that a Docker file really contains is a list of commands. And I have a subset of commands listed here. They're all shouty and capital lettered. From is the command that's going to be listed at the very top. And what we're going to do is define a base container to build from. So there are folks that spent a lot of time on designing and building various Docker images. Some are officially from companies like Docker, Google, NVIDIA. A lot of software platform companies provide their own Docker containers as well and images that you can use. You can also imagine that when you build a container, you essentially are executing commands. So various commands that you would normally enter into a command line, like setting an environment variable, changing your working directory, copying or adding a file in, and then running an arbitrary command. You should be able to do all of those things. So we introduce additional commands that allow us to do that. So this is a streamlined implementation of a Docker file that the computer science department uses. So at the top, we'll have the base image. So Arch Linux does have a base image, so I don't have to worry about manually configuring a base Arch Linux installation. And we have a few commands here. So first, we have this add command. Now, add is going to take a file that's stored locally on your machine and copy it over to the the container. And so we have this Autolab executable that we're going to copy over. And then I have a script that's automatically going to add a user and configure user permissions, etc. So we'll add that script over and copy it over to temp. And then we can run various commands. So we can run this add user script where, I want to add a user with the name of user and a default password of password. Not the most secure, but we also don't want to have the container run as root by default. That would not be a good idea. Then we're going to use a mirror that's closer. So instead of going to some default, we'll pull information from a Rutgers mirror. And then we're going to install our base packages. So we have the ability to install any packages we want. So being able to have rsync or SSH or Git, curl, command line editors like Emacs, Vim, Nano, etc. So we'll do that, and then we'll clean up all the cache files. So we don't need any of them. And then finally, we can switch the user to be the user account that we created and set the working directory for that user. So essentially, this provides a base Arch Linux distribution that also contains our AutoLab command line utility. And so we use this image as a base for all of our others. Now, you'll notice this doesn't really have anything related to development yet. Nothing related to any language whatsoever. So what we can do is build upon this Docker file and say, hey, when we want to develop in C and C++, there might be a bunch of compilers or libraries that we want to install. So we can install, GCC and Clang and LLVM, CMake, Ninja, the Boost libraries, a couple unit testing libraries, GDB, debuggers, Valgrind, and maybe a couple other of small images as well, packages. And what we also want to do is grab files from maybe other places as well. So there's a user-supported repository, the Arch user repository, and we might want to install additional packages from there as well. So do that too. So so for C and C++, this is what we're going to use. And then at the end, we specify this entry point, which means that at this point, this container can be used by a student. So they could theoretically run and use this container and develop in C and C++. And so they would be dropped into a bash shell and go from there. Mark's mentioning image magic will never go away. Yeah, we actually use it for one interesting lab, and it's just kind of nice to have those commands. Christian, yeah, we use GCC pretty much all the time. So, but that's for C and C++ development. What about Java? Well, we can install the OpenJDK, the associated source files and documentation, and include build tools like Ant, Maven, Gradle, and the JUnit unit testing library. So we can install all of these files. This one's pretty short. And then we can just, again, specify the entry point. Alex is asking, what's my thought on using Docker instead of something else like Vagrant? Honestly, I don't really have an opinion on it, but I do think that for us, we wanted something that was less of a pain point, and this is supported with just by installing Docker and having a single extension in VSCode. And it can run on student machines, it can run on servers. We're not really even focused on networking here. Like, we're not building services. we're building an environment as a service. It doesn't have to communicate to any other service. So the advantage here is that it's essentially a drop-in shell. It's more of an alternative to deploying a virtual machine. So that's why we're using Docker. And then finally, like if we want to use something like Python, I could install the Python packages in Arch, but really they're not the greatest. So instead, I just pull down a version of Miniconda, install that, and configure it and make sure that it runs. So I'm just pulling down Miniconda and installing that. To give you an idea of the types of containers and the hierarchy that we support, we use the Arch Linux base image, so that's up at the top. And then from that, we define our own base, which was the first Dockerfile image that I showed you. And then from there, what we'll do, or what we have, are a bunch of other images that focus on particular languages. So for C and C++ development, for Python, for Java, for other languages like OCaml as well, or JavaScript, or the .NET framework, or other things like that. So, and what's nice is that for each one of these languages, we're only installing the packages that are necessary for development with that language. So if a student is taking a course that uses C++ and then a course that also uses OCaml, they both use the same base. So they don't need two separate, big files. What they do is they have this shared base, and then they're only going to pull down the additional files, like the additional Docker image for C++ development, and then the additional Docker image for OCaml development. So they don't need to pull down everything. It's only the additional components. So there's space saving happening with containerization as well. Beyond that, if we want to extend a little further, for students who are developing, graphics applications, installing OpenGL, GLM, various libraries and tools, and even for AI, so being able to install and run TensorFlow with Keras, or doing theorem proving with Z3. We can pull all of that down as well and have it already configured and ready to go. In terms of running a container, we have two real options. Option one is just running it from the command line. So as a student, or you could say docker pull mucsci/python, and it will download all of the necessary images, and then you can run it interactively. So the TAC IT essentially means, hey, I want to run an interactive session and use or emulate TTY. And then you'll be able to execute that container and work on it. And you'll be dropped into a command line, and you'll be able to run Python and edit files and run them. The downside is that you don't by default have access to your computer files. You can mount a local directory with Docker, but then that's another step that we would have to tell our students on how to do, and that can be a little painful at times. So without mounting a local directory, they're going to be limited to container local editors and programs. We also want to have reproducible grading. I mentioned, we want to build these containers. Every single semester, what we're going to do is update all of the Linux Lab packages, rebuild all of the containers, push them up to Docker Hub. And then we can share these development environments with our students. So what they get graded on, again, is the same as what they're developing with. and what resources the department has. So we really do have a unified architecture here. So I'm gonna pivot the talk now to actually using Visual Studio Code with the Devcontainers package. So if you download and install Visual Studio Code, you'll be able to click on the little extensions icon on the left, and you can do a search for remote containers and install this extension. And they have a very extensive README here. I really didn't want to have my students need to go through troubleshooting anything here. So what I've done is we wanted to provide these dev container projects. We do have an open source repository that contains all the dev containers that the department uses. And we have predefined projects configured for C and C++, Java, OCaml, JavaScript and web development, Python, .NET, Swift, and many other languages and tool chains as well. What's really nice about these dev container projects is that you can automatically have extensions be installed and configured. You can automatically mount directories to your computer within the container, and you can have it preserve all settings and changes by writing everything that would have gone into a container into a local directory mount that will automatically get mounted upon the execution of the container. So I have a short dev container project that, when someone downloads it, it really only contains 3 files, hello.cpp, a make file, and a readme. But then there are also a couple hidden files. So specifically, if we have a .devcontainer folder, which is hidden on Unix systems, inside of this folder is going to be a devcontainer.json. And this devcontainer.json is what we package up and provide for students. And it has a bunch of different things. So at the top, you have the ability to specify an image. We could also specify a Docker file, but then that doesn't mean that students will always have the exact same version of the software. If they're always pulling down from Docker Hub, then we control the update. We also have various workspace mounting and additional mounting to ensure that settings are preserved and that they are able to access files stored on their computer. We also have the ability to specify a list of extensions, which will automatically be installed when we enter this dev container for the first time. We can also specify any number of Docker arguments. So in order to do debugging within a container, you probably want to add a few extra commands when you run the Docker container. So we do that automatically for our students. We can also specify container environment variables, change them, and then also provide settings for various extensions or disable phoning home to Microsoft. We can do that by default. So when you open up this folder in VSCode, once you have the extension installed, it will actually prompt you. It'll say, hey, this folder contains a dev container configuration file. Reopen the folder to develop in a container. And so you just have to click this reopening container button, and then you'll be dropped into this this development environment where all the files exist locally. You can create them, you can edit them. They're being live updated on your file system. So if you hit save, then the original files that were on your computer have been changed, but you're modifying them within this development environment. So you could be using a computer that has no compiler installed. You could be using this on Windows, Mac, or Linux, and you have access to GCC 10. You have auto completion, syntax highlighting, all of that stuff. So it helps students as well, because then again, they don't have to worry about configuring an IDE. They just need to use this pre-configured setup. We can also include additional files that aid with linting or code formatting or whatever else makes it easier to develop in these languages. So we're going to try to do a demo here. So let's see if this works.
Hi, Will. Just a quick update. We have about 10 minutes remaining. So I know you've been taking questions throughout, and there's not a ton. It doesn't look like there's any questions queued up. Just wanted to kick out the time there.
Perfect. Yeah, I've been going at the pace that I've been expecting.
Excellent. Great.
So
thank you.
This is great. So I'm going to open up the Python one, hopefully. And hopefully this will work. So again, we get prompted here. Folder contains a dev container, reopening container to develop. So we'll click this. Okay. And remember, this is installing, Visual Studio Code within the container as well. It's going to be remotely connecting to it. And so it's going through the setup process. I was hoping it wouldn't take this long. Yeah, Christian, I'm really glad that we have this ability to actually use this, because it really does make a huge difference on students to be able to work on assignments. So what's nice is that, if I think this is still actually loading, maybe. Let's see. Oh, yeah, it's still installing and configuring. Yeah, I kind of wish that we had this when I was in school. So, okay, here we go. So we're cooking with gas now. So we have this ability to just load a Python file, and I think we should get everything. And then what's also nice here is that the extension, okay, so it's going to prompt to install stuff. So yeah, we have to install Python stuff, but we also get interactive Jupyter notebooks within Visual Studio Code, which is pretty cool. So we have this ability to, just open up a Jupyter notebook and code away and have it work. Yeah, Greg's mentioning that Docker Desktop isn't available yet on Apple M1 Macs. That's true. I believe they're still fighting with Go right now, which is a dependency for Docker and everything like that. Jay is asking, Visual Studio is open source. Visual Studio Code is has an open source repository on GitHub. What you most likely install from Microsoft does have some closed source components. For example, their remote SSH extension is closed source. And the version of VSCode that they run inside of this container is technically closed source, but everything else is open source. So all of the extensions that you can install, they are open source. Students are primarily using Eclipse when they use Java. Okay, this is cute. I'm just going to open up a different one. And then when they move on to C++ and other languages, we often try to pivot them to using Visual Studio Code just out of the ability to be able to use this development environment. Yeah, so I got a question about debugging. I probably shouldn't have chosen the Python one, so let me open up the C++ one instead. Two things that Francis have found useful is to mount a volume for local SSH, so you can easily push to remote. Okay, and then he provided a link there to the file system boost. Yeah, Christian, I'm actually going to show you a debugging example really quick, assuming that this loads in some reasonable amount of time. In the meantime, I do want to say a couple of I have like 2 more slides. In terms of statistics for like this actually being in use for the fall, we had 4 classes that I know there were students who were using Devcontainers. Maybe not all of the students, but a decent majority of them. So, we had, about 140. Now, some students were concurrently enrolled in more than one of these, but at least in terms of impact, we had about 140 seats impacted. And then we were also using a lot of this infrastructure for autograding. So 75 students taking programming 1, about 50 students taking programming 2. 45 students taking computer architecture. And I think there were 20 to 25 students in computer graphics. So this has impacted, over 300 enrolled student seats for this. So it's pretty valuable. I also just want to shout out to colleagues, contributors, and users. So either folks who have used it or used it for auto grading, used it for, as a resource to their students. So Stephanie Schwartz, Chad Hogue, Gary Zappetti, Chris Kane, Jay Nancy, they're all colleagues in the computer science department who are either using the auto grading platform or helped me with debugging this. Cole is a student who's actually helped contribute a couple bug fixes. Ed Schwartz is the person who really got everything started with AutoLab along with Stephanie and all of the computer science students. So if I come back over here and I set a breakpoint, and I think I can run this. And so we are debugging. We're cooking with gas. Now, the way that GCC ends up representing some of these isn't great, but we do get the V, 5.4. So you can step through. I think you can also hover over. It'll tell you the current value. And this is for C++. So this is arguably one of the languages where it sucks the most for debugging in comparison to, other languages like Java or Python. So yeah, all of this is here. You can set watch points. You can see the call stack. You can set additional breakpoints as well. Resume execution as needed. Come down here, we have our vector. So I think I'm about up with time. But if anyone has any additional questions, you can always message me in chat. You can also email me. My email is william.killian@millersville.edu.
Great, Will. Thank you very much. It's always I don't if you haven't given a talk before, I don't know if folks realize just how time consuming it is to put together a great talk, and we definitely want to thank you for putting together a great talk for us this morning. Job well done. So thank you all for joining us for Will's terrific talk.